In this video, we're going to look at another Boyle's Law problem from the book. This is on page 480. It's problem number 10. Problem number 10 reads like this: what pressure in atmospheres is required to compress 1 liter of gas at 760 millimeters of mercury pressure to a volume of 50 milliliters? All right, so there's a couple different things going on here that we need to pay attention to. So if we read this again, what pressure in atmospheres is required to compress? First of all, the gas volume is given in liters, and we are asked to change it to milliliters, right? So we have to pay attention to that. And also, the pressure is given at 760 millimeters of mercury in millimeters of mercury, or torr. And the question asks us to find it in atmospheres. So we're going to have to do some unit conversion as we go here. But let's first make a table of the variables that we have. We have 1 liter of gas, and liters is a volume unit, so that's volume 1. So we have 1 liter of gas, and the pressure that's associated with that is 760 millimeters of mercury. And we are going to find the new pressure, provided that we change the volume. We'll call it volume 2 to 50 milliliters, and we are trying to find the pressure associated with that. All right, let's do some messing around here with units. Get rid of the unit conversions stuff out of the way right now. If we look at this, 760 millimeters of mercury, you may recognize that 760 millimeters of mercury is, by definition, 1 atmosphere. You can go ahead and do the unit conversion if you want to, or you can just look at that relationship we had in class, or there's also one in the book that shows us that is 1 atmosphere. The other thing we need to do is we need to convert this. Well, we're going to go to liters, and 1 liter is 1,000 milliliters. So the milliliters will cancel out, and this will be 0.050 liters. Okay, we're using Boyle's law, and if you haven't already watched it, I would suggest you watch Boyle's 1, because in there we arrive at the equation that V1P1, so the volume pressure set at some temperature for some amount of gas, equals that same product if we measure it a second time at some different pressure or some different volume. And for this problem, we're looking for P2, so we'll divide both sides of this by, we're looking for P2. I'm sorry, we're not going to divide by P, we're going to divide by V, aren't we? We're going to divide both sides by V2 to get rid of it. And so P2 is V1P1 over V2. We're ready to plug numbers in already. V1 was 1 liter. P1, we changed it and we found it was 1 atmosphere. And on the bottom, V2, we found to be 0.05 liters. When you do that, 1 times 1 divided by 0.05, you find that it's 20. And the units of that, well, if liters cancel out, will be atmospheres. Technically, let's be careful here, it's 20.0 atmospheres, because there were 3 significant figures throughout. All right, so there we go. 20 atmospheres is what the pressure needs to be changed to in order to shrink the gas down. So let's see if that makes sense. The pressure now is 20 atmospheres. Before it was 1. Does that make sense? Did the volume go in the opposite direction? And indeed it did. It went from 1 liter down to 0.05 liters. All right, so we have another Boyle's law problem.